Hello everyone, welcome to this video where we are given the following examples. And what are we trying to do? Well, we want to be able to learn how to find unknown angles in a right angle triangles using trigonometric ratios. Okay? And this is just a good practice that if the degree of accuracy is not specified in the question, and so it's not an exact value, we usually give the answer correct to 3 significant figures. But before that, this is a good practice that we do try to give our working to around 5 or 6 significant figures. Then final answer to be in 3 significant figures. And if the answers is going to be in degrees for the angles, we do give our answer to 1 decimal place if the answer is not exact. Okay? And in that case, the working we usually give to 3 decimal place. And without further ado, let's start to solve the first example here, where we are required to find the value of the angle theta in each case. So the angle is here, and our answers to be corrected to 1 decimal place eventually. So let's look at the first example. So again, at the side, this is a good practice that Mr. Tan here usually like to write the tuaka so. And with respect to the angle that we will be using or finding, in this case we are finding it, then we are going to identify the sides that have the known sides. So in this case, 12 and 14. So the side with value of 14, because it touches the angle, this is actually my adjacent side. And this will be my opposite side. And since I have O and A, which trigonometric ratios do you think I should use? Yes, good job everyone. So I'm going to use the tangent ratio. Tangent angle theta is equals to opposite. O is 12 over my adjacent side, in this case is 14. And therefore, to find this angle theta, all we have to do, we have to make use of our tangent inverse. And armed with our scientific calculator, do check that the calculator mode is degree mode, okay? Letter D, And once you have that, then go ahead and key into your calculator. You should get a value of 40 point. Since this is going to be angles in degrees, I'm going to leave my answer to 3 dp first, 3 decimal place, followed by final answer 1 decimal place. And that's it for example A. So if you notice, the approach, Mr. Tan always start by writing down the 3 possible trigonometric ratios. Then I identify the sides with respect to that angle that we are finding before I decide, which ratio that I could use. All right, so let's try it using Mr. Tan's approach. Twa, ka, so. And my angle is here, angle theta. This happens to be my longer side, hypotenuse, H. This side happens to be my adjacent side since it touches the angle that we are finding. And with A and H, A and H. Which of the three trigonometric ratios should I use? Yes, in this case, we are going to use the cosine ratio, where cosine of the angles is equal to A is 2.8 divided by my H, 6.5. And in order to find the angle, now we are going to use the cosine inverse with a -1 down there. And this will give me a value of, as I am keying into my calculator, do make sure that your calculator, the mode is in degree, alright? And you should get 64.484 when I round it to 3 decimal place. Final answer to be given in 1 decimal place when the angle is in degrees. So are you guys getting the hang of it? Because if you do, this is what I suggest. Before you continue watching the video, do pause the video for the next example or the next 2 examples. So I will have my Tua Kaso. And in this case here, my angle is here. And so, with respect to the angle, this side happens to be my hypo, the longer side. It is, and this side happens to be my opposite side. So with my O and my H, O and H, then I should be choosing the brilliant sine ratio. Yeah, so sine theta, angle theta is equals to opposite 18. O divided by H, so is over 22.7. So in order to find the angle, we will have to use the sine inverse with that -1 at the top. 18 over 22.7. Again, this is, I cannot remind you all further. Do make sure that your calculator is in degree mode, since we are working with degree for all examples here. And you will get 52.462 when I round it up to 3 decimal place. Final answer 52.5 in 1 decimal place when the answer is in degrees. And let's move on to the last example. And so again, if you want to try on your own first, do give the video a pause. So I start off with writing the 3 decimal place here. Okay, Tua, Ka, and so, and angle is here. So this happens to be my longer side, and this happens to be my adjacent side. So with A, H, which ratio should I use out of the 3 trigonometric ratio? Yes, cosine. So you will see cosine of the angle theta is equals to A 17.6 divided by my H 20.5. And therefore, to get the angle theta, we will have to use the cosine inverse. Again, please do make sure that your calculator is in degree mode since we are finding angles in degrees. 30.847 when I round it up to 3 decimal place, followed by 30.8 degrees, 1 decimal place. And with that, that's the end of this particular video where we are trying to find unknown angles in a right angle triangles using the trigonometric ratio. And at any point in time, if you like this video, do give it a thumbs up. And if you like, just subscribe to my channel as I bring you more videos on mathematics. Thank you and have a nice day.